Geometry lesson. Okay. I'm gonna start. Today I want to talk about the pi and phi. How are these two numbers connected? Is there an easy way to show its interrelationship? I'm going to show you one way that I have found that is very simple. I haven't seen this geometric explanation anywhere, so let's see if you agree with me. I start with an arbitrary line. This line I will use as a radius to make a circle. Now let's see that all the instruments are working. So we make a circle from this, like this. In here I also want to draw the diameter. So let's do like that. Okay. I want to stress that the relationship between the radius and the diameter is in a 90-degree relationship. We also know that the proportion between the radius and the diameter is 1:2. That's very important. So let's call the radius, we call that A. That equals to the radius. We can call the diameter B. So they are in proportion 1:2. So for simplicity, we use that the radius is 1 and the diameter is 2. Now I'm going to show you a transformation. We imagine that the radius is free to shift along this diameter. So what I want to do is I add the radius, I move it down to the very edge of the diameter. And if I connect the two edges, I will get a triangle like this. Now the size of the triangle will be 1, 2, and because this is a 90 degrees relationship, so it is a right angle triangle, and we calculate it by the Pythagorean theorem. So a squared, the radius is a, so that's 1 times 1, that's 1, plus b, which is 2, 2 times 2 is 4, so that equals 5. So a square of the diagonal would be 5. So one side of that square is of course root square 5. Root square 5 is what gives phi its irrationality. So as we have this root square 5 now, what we're gonna do is we're gonna put the compass, stretch the length of the hypotenuse. I put the needle at the edge of the radius, and from here I fold it out. So we get a circle there. What I want to do then, next, I want to add this length of root square 5 to the radius. So that's root square 5. So now we have a length from here to there, which is 1 plus root square 5. Then we have another length which is equal to the diameter of the circle, which is 2. So if I take this line divided by this line, I will have this equation. 1 plus root square 5 divided by 2. That equals 1.618033 and so on. That is the equation for phi, the quadratic equation for phi. So these two lines, they are in golden proportion. So I want to do a golden rectangle from here. Then I add the radius up there instead. I do like this. There we go. I do the same procedure but reverse. And we can add this root square 5 there. And we add these two lines together, just like that. Okay, there we have a golden rectangle. So here we have created the golden ratio and the golden rectangle from a circle. We started with a radius or a distance. A distance can also be thought of as the length between 2 points. So very, very easy, starting from what they call 0 dimensions, just a point, and then a line, and continuing. So, and also there's one more thing we can do here to make it complete. So we really get the relationship of pi and phi, where this circle and the side of the golden rectangle intersects. If we join these 2 points, we will get a perfect square. So we can also see this as this is the unit circle, this is the unit square, and this is the unit golden rectangle. All 3 forms sharing one central line, which is the diameter of the circle. So the diameter of the circle is the same as the side of the square and the side of the golden rectangle. Here you can see also that there's 2, because we make a square in the middle, that divides the golden rectangle into another golden rectangle. So we have a small golden rectangle here and we have a big golden rectangle. So this is a very simple way, a very fundamental way how to connect pi and phi.